Hello students, welcome to eDufundae. I am your chemistry mentor for the topic classification of elements and periodicity in properties, and we are going to discuss the topic trends in atomic radii of elements. And it can be explained in terms of nuclear charge and energy level. So we can understand the trend of atomic radii in terms of these two factors, which are nuclear charge, or we can say effective nuclear charge, and energy level. So let us see what is the trend of atomic radius in a period. Across the period, when we move from left to right in the periodic table, the outer electrons are in the same valence shell and nuclear charge increases, resulting in the increased force of attraction on the electrons by the nucleus. So what is happening? जब हम पीरियोडिक टेबल में लेफ्ट से राइट पीरियड इन अ पीरियड मूव करते हैं, देन व्हाट इज हैपनिंग, एक पर्टिकुलर शेल में नंबर ऑफ इलेक्ट्रॉन्स इंक्रीज कर रहे हैं, which is increasing the effective nuclear charge. How? Number of electrons जब increase करेंगे, then nuclear will have to strongly pull those outermost shell electrons towards itself, which is increasing the effective nuclear charge, and as a result of which the atomic radius decreases. So as the nuclear charge increases, atomic radius decreases across the period from left to right, because there will be the increase in effective nuclear charge, which will result in the shrinking of the size of the atom as we move across the period. So here is the periodic table, and we are having second period over here. And when we are moving across the period from lithium, beryllium, boron, carbon, nitrogen, oxygen to fluorine, then you must be noticing that there is a decrease in the size, or we can say atomic radius, up to fluorine, because the number of electrons in the same shell are increasing, which is increasing the effective nuclear charge from lithium to fluorine. Next is the trend of atomic radius in a group. So in a group, the atomic radius increases because the number of shells increases in the same energy level. जब हम down the group जाते हैं, then what is happening? Number of shells are increasing. Since the valence shell electronic configuration is similar, but number of shells are increasing. So outermost shell is becoming far away from the nucleus. So that is why atomic radius increases down the group. So this is the periodic table, and we are having group 1 elements over here, and lithium, sodium, potassium, rubidium, then cesium. जैसे जैसे हम down the group जाएंगे, number of shells are increasing, because lithium में we are having 2 shells, sodium में we are having 3 shells, potassium में 4 shells, rubidium में 5 shells, cesium में 6 shells. So number of shells are increasing. That is why atomic radius also increases down the group. So this is the summary of the topic. Atomic radius, that is inversely proportional to nuclear charge. जितना ज़्यादा nuclear charge, उतना छोटा atomic size. Because across the period atomic size क्या करता है? Decrease due to the increase of nuclear charge. And when we talk about the trend of atomic radii along the group, then we can say that atomic radii is directly proportional to number of shells in the same energy level. जैसे जैसे number of shells increase करेंगे, वैसे ही atomic radius also increase करेगा. Next is the exception in trends in atomic radii of elements. Let us see the exceptions. Noble gases are the exceptions. It is because the noble gases are compared with the van der Waals radius, which is always greater than the covalent radius. We have already discussed that जो van der Waals radius है, that is non-bonding radius. And it is a cloud, or we can say it is just an attraction. So noble gases क्या करती हैं? They are very low chemical, they are having very low chemical reactivity and their atomic radii are non-bonded. That is why we consider van der Waals radius in case of noble gases. And since van der Waals radius is greater than covalent radius, that is why noble gases are the exception when we talk about the atomic radius. That's all about this topic. Thanks for watching.